Hello everyone. I am Mrs. Pragati Male, working as an assistant professor at AISSMS Institute of Information Technology, Pune. This video is about the subject Theory of Computation from third year Information Technology. Today So in my last lecture video, we have seen what is pushdown automata and the various operations of pushdown automata. Pushdown automata is formally defined as a seven tuple where Q is a set of states, sigma is a set of input symbols, whereas gamma is a set of stack symbols. Q0 represents the initial state. Z represents the initial stack symbol, F is a set of final state, and delta is the transition function, and the transition function is given as Q into sigma union epsilon into the stack symbols, and this leads to on right hand side we have the union of states and the uh, gamma closure. So the transition function, it depends upon the current state, it depends upon the next input, and it depends upon the stack symbol. Whereas this particular Q into gamma closure implies that the next state could be any state which belongs to a Q, and it can perform various operations like push, pop, or no operation on the stack. So this is the transition function representation of push down automata, and in this transition function the left hand side, that is this particular portion, that is q into sigma union epsilon into stack symbol, implies that the transition is based on current state q0, then a current input a, and B, which is the topmost symbol. So the transition function, this particular thing indicates that the transition is based on these three elements. And then let us see some operation with understand how different operation with respect to the transition function. And the second part, this particular thing, it implies that the next state could be any of the state belonging to the queue, and there could be any operations like push, pop, or no operation. So now let us see each operation. So here this particular example shows that you are at the initial state Q0, current input is A, B indicates the top symbol, and on the right hand side this particular bracket implies that you have moved to the next state Q1, but there is no operation because B is replaced with B, that is there is no changes in the stack. Now let us understand the pop operation. So here you can again see Q1 indicates the current state, A is the current input, B is the topmost symbol in the stack. Now you can see this bracket implies that we have moved to the next state Q2, and we have a stack represents empty. That means the B is replaced with epsilon, that is the B is popped from the stack. It is removed from the stack, and epsilon means the empty string which is the current top. Now let us understand the push operation which is given by this particular transition uh, uh, format. So this transition will perform a push operation. It will push A onto the stack, replacing B with AB. This means B is replaced with AB. So we have pushed A into the stack, and let us see one example where the language is defined as a raised to n, b raised to 2n, and n is greater than 0. So now in this case, what logic we can apply to construct a push down automata? So the logic is we push the sequence of A onto the stack, and for every read for every B symbol which is read from the input tape, we need to remove A from the stack. But there is some variation because B is 2 times more compared to A. Then in that case, for first read of B, we are going to skip, that is we are not going to perform any operation, that is no operation and no changes in the stack. And for second read of B, so when we get next second B, that time we are going to pop one A. So for one B, skip, second B, pop, next B, skip, and for the next B, pop. So this is how we are going to construct the push down automata. So now let us start with our example, and let us see the first input A, and let us write the transition function. This shows the initial condition where my current state is Q0, my current input is A, and the top of the stack is pointing to Z0, which indicates that this is the initial state. So when I read the first input symbol A, I push A into the stack, and at the end of the transition function, this is how my stacks look like, with Z replaced with A Z0. The same thing can be shown with the transition diagram with Q0 in the state, initial state, that is the start state. We read A and we that push A into the stack, and now the stack is updated to A Z0. Now for the second A read. So let us see the operation transition function is the current top of the stack is pointing to A. A is my current input symbol, and on reading A, I am going to push A into the stack. So the same thing can be seen with the transition diagram. You are at Q0. When you receive A, you push A, and the stack is updated to A. Then on receiving the next B, what we have to do is in the previous example for A raised to n, B raised to n, for every for every B, we used to pop A. But now here we have 2 raised to n. So for every B, if we pop A, then this 2B will be remaining, and our stack will go to empty state, and then that string will be rejected. That means our push down automata will not accept the string, and then it will go wrong. So we need to change the logic. So what we can do here is, for first B, we can skip A, first A, and for second B, we will pop A. So skip and pop, these are the operation we'll do. That is, for first read of B, we will skip, and for second read of B, we will pop. Okay, so let us see the transition function now. So top of the stack, current input is B, the top of the stack is A. Okay, so for this we are not going to perform a pop operation, that is we are just simply going to skip, so no operation. Okay, so there is no changes in the stack. But there is a transition that on receiving B, we move on to the next state with no changes to the stack for the first B. Now, on reading the second B, we are going to pop one A. So my transition will be function will be Q1. B is my current input. A is on the top of the stack. So on reading next B, I am popping A. So by popping A, I am not going to push anything. So epsilon means empty, and I have performed a pop operation where A is popped from the stack. And I am making a transition to the new state Q0. So at Q1, when I read the second B, I perform a pop operation where I pop 1. Now let us see read the next B. Now what happens at this next B? This is the transition function where now I am at Q2, my current input is B, my top of the stack is A. So now I have to again skip A. That means I don't have to perform any stack operation. So in this case, there is a transition from Q2 to Q1 with no stack operation. So this is indicated by A/A. So there is no pop operation. For the next input of B, now we have to perform a pop operation. So we need to pop one A. So my transition function will be Q1 is I am at the Q1 state, current input is B, and my top of the stack is A. And now I am going to perform a pop operation. So my stack uh, will replace A with the epsilon. So this can be A is. So this is how for we are successfully able to design a push down automata for A raised to n and B raised to 2n. So because here B is twice A, so we are going to skip in for first read, and we are going to perform a pop operation for second B. This is how we reach to the end of the uh, uh, we reach to the final state where the stack empty, we are at the stack empty condition, and we have successfully read entire string, and this string is accepted by our push down automata. So now let us just have a look at all the transition functions which we have done for this construction. So my final push down automata, which is represented by the 7 triple, is as this. So we have 4 Q0, Q1, Q2, Q3 states. Input is A and B. My stack symbols are A and Z0. Q0 is my initial state. Z0 is my top of the stack. Delta, that is the transition function. So we have written this many transition function to perform to accept the string of the form A raised to n, B raised to 2n. And our final state F is nothing but the Q3. On reaching the final state, our stack is empty. So we have satisfied both the condition, that is we have designed a push down automata for the language which is accepts which reaches the final state along with the stacked empty condition. So thank you so much.